Okay, finding zeros of functions. Now, this is something that you guys have already been kind of doing. I guess most of this is just going to be review. But some of you guys want it and need it. Now, when you guys are looking for zeros of functions, check it out. Let's say you have this random function right here. This random function looks like this. It goes up, down, and it goes up like that. Okay, random polynomial function, there you have it. Zeros are the dudes right at the x-intercept. So this is a 0, right here. This is 0, and that's a 0. Okay, you guys are like, what? How come you just call it x-intercept? There are reasons why I just can't explain to you right now. It's just, reasons why I found out in college. I'm like, oh, that's why they called it 0. Oh, that's why they call it a root. That's why they call it an x-intercept. But this has, for you right now, you need to know that this has a bunch of names. It says it's called an x-intercept, it's called a root, it's called a 0, and in calculus they call it the critical points. Okay, so roots, x-intercepts, 0, critical points, they're all the same. All right, you find them the same way. So when we go to our first problem right here on letter A, how do we find it? We take out this f of x and we set it equal to 0. So that's how you find x-intercepts, right? You set the y equal to 0 and f of x is 0. And so now your job is to see if you can factor it. If you cannot factor it, what are our other options? The quadratic formula. Or you can complete the square and do it that way. I think I prefer quadratic formula better, but let's see if it's factorable first. What number goes on top? Negative 30 and 1. Okay, 6 and 5. Yeah. Which one's negative? The 5. The 5, because it's in positive 1. Yeah, you're down, you're down. So we had 3x squared, and we're splitting up this with the two new numbers that we found. Negative 5x. And guys, you don't have to write this down if you totally get it. This is just for, if you're like, oh, I need review on this, then do it. Okay, so what can I divide both of those by? 3x. And then I get x plus dose. What can I divide both of those by?
-5.
Yes, and you want a -5 because then you get x plus 2. And then you can take an x plus 2 out of both of them and finish your job factoring. So x plus 2, I took them out. And then what am I left over with? The 3x and the -5. Boom, we're factored. It equals 0. And that's what our whole goal was, so that we don't have any more x squareds, and we can use a 0 property to solve this. To use a 0 property, you just set each of these factors equal to 0 and solve them. You'll get x equals -2 and x is 5 over 3. So those are your two solutions. Those are your two x-intercepts. Those are your two roots. Those are your two critical points for this function right here. Let's look at the next one. For the next one, you have to do the same thing. You have to set it equal to 0. Your y has to be 0. So we have 0 equals radical 10 minus x squared. Alright, so let's solve this one. In order to get that x alone, we first got to get rid of this operation called the square root, also known as radical. What's the inverse of him? Squared. So you square both sides. 0 squared is 0, no problem. On the right side we have 10 minus x squared. How do we solve that? Well, subtract 10 from both sides, so then we get -10 equals -x squared. Oh, both sides have a negative. How do you get rid of the negatives? Divide by -1. So I divide both sides by -1. Now I have 10 equals x squared. Alright, can I get the x alone now? Stop hating me, Manalai. Yes?
Couldn't you just add x squared and then x squared equals 10?
Oh, you could have done that way too. Yeah, you could have added x squared instead of subtracting 10 the way I did it. So I take the square root of both sides. You get x equals plus or minus radical 10. There you have it. Other two zeros. Alright, for C, same thing. Set it equal to 0. We have 2t minus 3 over t plus 5. Now just like getting rid of fractions, if you had something cute and little like this, like look, this is cute and little. You're like, oh, that's so cute. Because you guys know how to do that. How do you get rid of this denominator right here? You multiply it. You do the inverse. This says divide by 2, so multiply by 2. So I multiply both sides by 2, and then these two will cancel out, and then I'm gravy. I just solved it. X equals 6. Over here, what's the denominator? Okay, don't let the little expression scare you. You have to multiply both sides by t plus 5. And just like you were able to cross the 2's out right here, you can cross out the t plus 5's right there. Oh, that's sick. Okay, so now I just have 2t minus 3. And what is this side? What are you going to get on this side? 0. 0 times anything is 0. So I finish solving it. I get 2t equals 3, and then t equals 3 divided by 2. There's your last 0. Okay, now here it's the same example, but I'm throwing up the pictures of the graphs. Guys, I got this straight from the book. These are the same problems that they solve in your examples in the book. Look at it. Look at this one right here. -2, 0, and 5 over 3, 0. Those are our two answers, right? 5 over 3 and -2. Yeah. This one right here. This one, when you graph it, it gives you a semicircle. Is that a function?
Yes.
Heck yeah, it is. That's a function. We have negative radical 10, and then a positive radical 10 is right there. And then this one right here, this one has this line right here that crosses the x-axis. This one actually has two lines. The other line you can't see. It's, I think it might be right there, but you can't see it because we only care about this one. This one only this line crosses the x-axis. And look, there's our 3 over 2 right there. Questions about the graphs? Let's finish this. Okay, where is each function rising and falling? We kind of did this, yeah?
Yeah.
For our DNA? So, let's do this quickly like we did in our DNA.